Good morning. Welcome to the SCSA Toolbox Tuesday. My name is Justin Brooks, Safety Advisor for the SCSA. I'll be presenting today's Toolbox. So before I start the presentation, I just want to take a moment to discuss an item or two before we get going. So this Toolbox talk is being recorded and will be available for later viewing on Facebook and our YouTube channel. So if you're not following our social media accounts, make sure that after your presentation, you give this video a like and a share, and follow our other pages to keep up to date on safety in Saskatchewan. So today we will be talking about confined space. So let me just share my screen with you guys and we will get moving. All right, so confined space. Many workers are injured and killed each year while working in confined spaces. An estimated 60% of the fatalities in North America would have been among the would-be rescuers. A confined space can be more hazardous than regular workspaces for many reasons. To effectively control the risks associated with working in a confined space hazard assessment and control program should be implemented for your workplace. Before putting together this program, make sure to review the specific regulations that apply to your workplace. Generally speaking, a confined space is a fully or partially enclosed space that is not primarily designed or intended for continuous human occupancy, has limited or restricted entrance or exit, or configuration that can complicate first aid, rescue, evacuation, or other emergency response activities. It can represent a risk for the health and safety of anyone who enters due to one or more of the following factors: its design, construction, location, or atmosphere, the materials or substances in it, work activities being carried out in it, or mechanical process and safety hazards present. So what is a confined space? Confined spaces can be below or above ground. Most people associate a confined space with just mines, but confined spaces can be found in almost any workplace. Confined space, despite its name, is not necessarily small. Examples of confined spaces include silos, vats, hoppers, utility vaults, tanks, water supply towers, sewers, pipes, access shafts, truck or trail tank cars, aircraft wings, boilers, manholes, pump stations, digesters, manure pits, and storage bins. Ditches and trenches may also be confined spaces when access or egress is limited. Barges, shipping containers, and fish holds are also considered possible confined spaces. So how does the Saskatchewan Occupational Health and Safety Regulations in 1996 define a confined space? In 266, you'll see that confined space means an enclosed or partially enclosed space that is not primarily designed or intended for human occupancy except for the purpose of performing work and has restricted means of entrance and exit. Hazardous confined space means a confined space that is or may become hazardous to a worker entering the confined space due to the design, construction, or atmosphere of the confined space, materials or substances in the confined space, work activities or processes used in the confined space, or any other conditions relating to the confined space. So hazards, what are the hazards in a confined space? So all hazards found in regular workspace can also be found in a confined space. However, they can be even more hazardous in confined spaces than in regular work sites. Hazards in a confined space can include poor air quality. So there may be an insufficient amount of oxygen for the workers to breathe. The atmosphere might contain a poisonous substance that could make the worker ill or even cause the worker to lose consciousness. Natural ventilation alone will not be sufficient to maintain breathable quality air. Hazards from asphyxiants. Some asphyxiants are gases which can become so concentrated that they displace oxygen in the air, so normally about 21%. Low oxygen levels, which is about 19.5% or less, can cause symptoms such as rapid breathing, rapid heart rate, clumsiness, emotionally upset, and fatigue. As less oxygen becomes available, nausea and vomiting, collapse, convulsions, and coma and death can occur. Unconsciousness or death could result within minutes following an exposure to simple asphyxiant. Asphyxiants include argon, nitrogen, and carbon monoxide. Chemical exposures due to skin contact or ingestion, as well as inhalation of bad air. Fire hazards. There may be an explosive, flammable atmosphere due to flammable liquids and gases, and combustible dust, if ignited, could lead to fire explosion. Process. So related hazards such as residual chemicals, release of contents of supply lines. There's physical hazards, noise, heat or cold, radiation, vibration, electrical, and inadequate lighting. Safety hazards such as moving parts of equipment, structural hazards, engulfment, entanglement, slips, falls, vehicular and pedestrian traffic, shifting or collapse of bulk material, barrier failure resulting in flood or release of free-flowing solid or liquid, visibility, so like smoke particles in the air, biological hazards, viruses, bacterial from fecal matter and sludge, fungi or molds. So many factors need to be evaluated when looking for hazards in a confined space. There's a smaller margin for error. An error in identifying or evaluating potential hazards can have more serious consequences. In some cases, the consequences in a confined space are always extremely hazardous. In other cases, conditions are life-threatening under an unusual combination of circumstances. This variability and unpredictability is why the process of hazard and risk identification and assessment is extremely important and must be taken very seriously each and every time one is done. So some examples include the entrance exit of the confined space might not allow the worker to get out in time should there be a flood or collapse of free-flowing solid. Self-rescue by worker is more difficult. Rescue of a victim is more difficult. The interior configuration of the confined space does not always allow for easy movement of people or equipment within it. Natural ventilation alone will not be sufficient to maintain breathable quality air. The interior configuration of the confined space does not allow for easy movement of air within it. Conditions can change very quickly. The space outside the confined space can impact the conditions inside the confined space and vice versa. Work activities may introduce hazards not present initially, and lack of communication between the workers in the space, the attendant, and the emergency response team. So when we look at why it's so dangerous, many factors need to be evaluated for those hazards in a confined space. So the entrance, exit of confined space might not allow the worker to get in and out in time should there be a flood or collapse. Self-rescue is more difficult. Rescue the victim is more difficult. Natural ventilation alone, conditions changing quickly. We've looked at all these different things that can impact the danger level of these confined spaces. So we've looked at the danger level. Now let's look at the preparation. The important thing to remember is that each time a worker plans to enter any workspace, the worker and supervisor should determine if that workspace is considered a confined space. Be sure the confined space hazard assessment and control program has been followed. The next question asked, is it absolutely necessary that work be carried out inside the confined space at all? In many cases where there have been deaths in the confined space, the work could have been done outside the confined space. Before entering any confined space, a trained and experienced person should identify and evaluate existing and potential hazards within the confined space. Evaluate activities both inside and outside the confined space. Air quality testing. The air within the confined space should be tested from outside of the confined space before entering in the confined space. Care should be taken to ensure that the air is tested throughout the confined space, side to side and top to bottom. Continuous monitoring should be considered in situations where a worker is in a space where atmospheric conditions have the potential to change. So, for example, broken or leaking pipes or vessels, or the work activity creates a hazardous environment, isolation of the substance is not possible. A trained worker using detection equipment, which has remote probes and sampling lines, should do the air quality testing. Always ensure the testing equipment is properly calibrated and maintained. The sampling should show that the oxygen levels are within the safe limits, so they're not too little, not too much. Hazardous atmosphere, so where toxic gases, flammable atmosphere is not present. Ventilation equipment is operating properly. That's a very important key of this, is to make sure it's calibrated and working properly. The results of the test for these hazards are to be recorded on the entry permit along with the equipment or methods that were used in performing the test. Air testing may need to be ongoing depending on the nature of the potential hazards and the nature of the work. Conditions can change while workers are inside the confined space, and sometimes a hazardous atmosphere is created by the work activities that the workers are doing in that confined space. So, for example, if we have machinery running, it may have tested fine prior to the machines being started up, but now all of a sudden the machines have been running for an hour and everything has changed. So when we talk about control, the big question is how are hazards controlled in a confined space? So the traditional hazard control method found in regular work sites can be effective in confined spaces. So these include things like engineering controls, administrative controls, and personal protective equipment. Engineering controls are designed to remove the hazard, while administrative controls and personal protective equipment try to minimize the contact with the hazard. However, often because of the nature of the confined space, and depending on the hazard, special precautions not normally required in a regular work site may also need to be taken. The engineering control commonly used in confined space is mechanical ventilation. The entry permit system is an example of an administrative control used in confined spaces. Personal protective equipment, with things like respirators, gloves, and earplugs, is commonly used in confined spaces as well. However, wearing of PPE sometimes may increase heat loss and mobility. So these situations should be carefully evaluated. When using PPE, always use as part of a PPE program. And be sure to evaluate all possible hazards and risks associated not only with the task, but also with some of the conditions that the personal protective equipment can create. Again, you never want to bypass the use of personal protective equipment. You want to just look for maybe even substitutions within that same personal protective equipment. For example, if your glasses are always falling off, you may look into safety glasses with a strap and that sort of thing, right? If the gloves stop you from being able to have mobile hands, maybe you want to look into something that provides the same or better level of protection with maybe a little bit more dexterity. So some other safety precautions. Many other situations or hazards may be present in a confined space. Be sure that all hazards are controlled. So for example, any liquids or free-flowing solids should be removed from the confined space to eliminate the risk of drowning or suffocation. All pipes should be physically disconnected or isolation blanks bolted in place. Closing valves is not sufficient. Use two blocking valves with an open vent or bleed valve between the blocking valves when isolating pipelines or similar conveyances to prevent entry of materials and hazardous containments. A barrier is present to prevent any liquids or free-flowing solids from entering the confined space. One of the biggest safety precautions is training and giving time to the employees, workers, or anybody entering a confined space to do a proper risk assessment. The opening for entry into and exit from a confined space has to be large enough to allow for the passage of a person using protective equipment. That's another huge one. Protective equipment should never be taken off or disregarded because it doesn't allow for proper entry into the space. Working in a confined space requires specialized knowledge, training, experience, equipment, and planning. This is never something that you want to chance just by winging it. Ensure proper planning of activities so that are conducted in a confined space is crucial to ensuring your workers are safe on the job and imperative to emission zero. Stay tuned to the SCSA newsfeed as we're working on some very special virtual reality training for confined space work. All right, so that concludes our Toolbox Tuesday on confined space. As always, if you have any questions about confined space or any other safety-related material, whether it be to course certification or just general questions on the Act and regulations, demonstrations, or any of the above, make sure to look us up on www.scsaonline.ca. And you can find all our contact information on that website, whether it's by email or telephone. So until next time, we'll see you next Tuesday for our next Toolbox Tuesday. And once again, stay safe.